Hello everyone, welcome to DNA 101 and evaluating post-conviction DNA testing cases. First, I'd like to say that this program is supported by two federal grants. Quattrone Center for the Fair Administration of Justice and RTI both receive federal money from BJA to conduct these programs. Lori, if you please advance the slide. As we go forward, the comments and other positions that are presented in this talk are not the position of the Department of Justice and are solely those of the presenter. My name is Dr. Adina Thompson. I'm with the Quattrone Center for the Fair Administration of Justice at the University of Pennsylvania Carey School of Law. I work at the Quattrone Center as support for post-conviction DNA testing grantees, and we provide that support in two ways. We provide opportunities like this training session, and we also help grantees match with DNA experts to conduct post-conviction DNA testing. So let's see, with that, I want to acknowledge a few housekeeping items. If you have any trouble with your technology during the remainder of the webinar, please drop into the chat. Folks from RTI are here to assist you. In addition to that, we'll be taking questions throughout the discussion. So if you have a question, as soon as you have it, please drop into the Q&A and ask it. A lot of what Lori is going to present today is quite detailed, and we want to make sure you ask the questions you have when they're relevant and when the slide is up. So please use the Q&A for that. And then finally, there will be a short poll at the end. Please do stay to answer those few poll questions. And without further ado, I would like to introduce our speaker today. Lori Montgomery is the section head at the Conviction Integrity Unit at the Michigan Department of the Attorney General. The Conviction Review Unit does post-conviction innocence work, looking for cases of potential wrongful conviction within their jurisdiction. Previous to this, at the beginning of her career, Lori was a DNA staff attorney with the Cooley Innocence Project, and for most of her career has worked at the intersection of science and the law. And there can be no better intersection than DNA, where these two things really come together. And this is an area that Lori has focused her work on, and we're really delighted to have her joining us today. She is a frequent presenter of talks like this, so without further ado, Lori Montgomery, please take it away for DNA 101.
Awesome. Thank you, Adina. So just like Adina, I have a few disclaimers for myself. First of all, I am from the Michigan Department of Attorney General's office, so any opinions expressed in this are of my own and not of Attorney General Dana Nessel or the department itself. Also, we at the department do receive federal BJA funding through a DNA grant as well, which I have to say was absolutely instrumental in starting our CIU. We was able to provide resources for staff and DNA testing and investigators. And really without it, I'm not sure our unit would be as robust as it is today. And finally, my third disclaimer is I'm an attorney. I am not a scientist or an analyst. When Adina and I were talking about this, we sort of wanted to make it more practical. And to me, the best way I learn is talking to other practitioners who aren't, super sciencey, so that I can kind of understand what's going on and put it into my own words so that I can have meaningful discussions with experts. So my goal here today is not to teach you Bio 101 so you can go pass your high school biology exam. My goal is to make it so that as practitioners, whether you're law enforcement, a student, attorneys, you're going to be able to review a case in post-conviction land, and then work with experts to determine what are the next steps in your case. And as Adina mentioned, please, please, please ask questions along the way. I really don't want to be talking for an hour and 15 minutes or however long they have me for. And if a question is too convoluted or case specific, my contact information is here. Adina's information is there. Please just get back to us and we can set up a call. So what we're going to be talking about today is starting with DNA 101. Again, not going heavy duty into science. Most of us avoided science and went into law, so I'm not trying to do that to you guys. And then we're going to go into how I review a post-conviction case, and then what I do and what questions I ask in order to determine if there is new DNA testing that can help identify the perpetrator. That language is really important because we're not here depending on which side of the V you are, to identify the person convicted. We're just trying to get to the truth. So try to identify the perpetrator versus, the defendant. All right, so first off, we put a beautiful double helix there just to make us look super smart. But I promise that's pretty much the only science I'm going to get into. In the criminal justice system, we aren't doing the same type of DNA that you would be doing in other justice or other non-justice communities. So what we're concentrating on here is just specifically what we do in criminal cases. So we are testing on specific strands that are more unique to an individual. It would not help us if we tested on a location that everyone shares, because that's not going to help me connect the victim to the evidence or the perpetrator to the evidence. What we're testing on in criminal cases are more what we call unique or discriminatory locations. It depends on your lab and when the testing actually occurred to tell you how many locations we are actually testing on. For example, in Michigan, our state lab is 23. There are private labs that are working from anywhere from 25 to 26. And then if you start to get a little bit more newer technology, they're now testing up to like 150. So it just depends on your kit and what lab you are working with. What alleles are is they create your, let's call, DNA signature. So we do overlap, and there are a certain amount of numbers that can be at any given location on your DNA strand, and we will overlap. But when you start to compound all the different locations that we're testing on, that's when it starts to be more discriminatory or unique to an individual. And that's what really helps us say, okay, statistically wise, this person is most likely to have contributed versus someone who could be excluded. I love to provide this slide to new attorneys or to attorneys who have never worked in DNA, or to my students or my investigators, because it kind of gets your brain working on, if I'm evaluating a case, where can I actually find DNA? And evidence right now, or testing right now, is so sensitive. The answer is basically everywhere. So you can get it from blood, semen, sperm, hair, saliva, bone, skin cells. That doesn't mean that each of those are going to provide a beautiful, perfect profile, but it at least is the start of a discussion of, can I get something from this item? And also the tests that you can perform will vary based on which, where your biological material came from. I also like to leave or provide the items on the right-hand side, which kind of gives you an idea of like what to think about when you're reviewing a case. So some things that people may not think about is, weapons and how it can be a double tool. So it can identify the perpetrator for the person holding it, and then it can identify, the victim if they're on the blade, let's say, of a knife. And what I've noticed in older cases is they weren't thinking about touch DNA. So really they were just concentrating on the blood. And now that's a huge avenue for us to explore if the knife hasn't actually been evaluated or, basically evaluated. Some other things to think about that sometimes people don't think would be good is like tape or duct tape or bindings, jewelry, and if anything like an earring or a necklace that's really intimate with your body, you're going to be shedding lots of skin cells and sweat. So they are great areas to find biological material. And one thing I do want to mention, because I think this gets overlooked, in post-conviction work, if you've been doing this for a while, a lot of the times our evidence sucks. It's just the reality of decades old cases where the evidence may have sat and been through, 2 or 3 floods, a couple fires. It has been, put into different storage facilities, not exactly kept great. And so sometimes you may actually have an envelope that once contained an item, but now it's empty. Don't overlook that. I've done a testing on an envelope that contained a swab before, and we were able to get a partial profile that was good enough to exclude if we had to. So also think about the fact of what those items, evidentiary items, could have actually been contained in, even if your items are now gone or destroyed. So I want to talk about the process. I want to make it clear that this is more of like a historical overview and approach. Things have changed as we've evolved and the test kits have gotten better. But if you're evaluating an older post-conviction case, you have to know their process back then, because that's going to help you evaluate what you can test now. So basically, obviously, the item gets collected, cool. It then gets transferred to the crime lab. They will go through a test, which is they call serology, and all it is identifying whether or not that evidentiary item has some form of biological human or biological material on it. And so they're testing for saliva, semen, sperm, blood, so on. I want to just warn you that these tests are presumptive. That means that they are not 100% accurate. A lot of the times, older cases will have overlooked an item who they didn't find a positive presumptive test for biological material, but in fact, it was there. So just because you read in a lab report, it was blood negative or it was sperm negative, don't just throw the item to the side and say, okay, this is going to be useless. You need to evaluate, especially if you have nothing left, whether or not it was just a faulty presumptive test, or is there touch DNA or skin cells that we weren't testing for back then. Next, the item is swabbed if it moves forward. The item will be swabbed if it's not already a swab. So a sexual assault kit will already have swabs, but items like a gun or a knife will need to get swabbed and then renumbered and retagged. That is also another major area of contention, because your sample is only as good as how you extract that material from your item. So if they, for example, on a purse, if they just swabbed, a 1 by 1 inch by 1 inch area, that's not going to be very helpful if the perp didn't touch that area. So it really does matter how you remove the DNA from your item for how good your results are going to be. So just because an item was analyzed or swabbed back 10, 20, 30 years ago, again, don't push that item aside. We might be able to reswab it, maybe do a different technique like soaking or using MVAC, which is, I call the Dyson of DNA. They take a vacuum and they vacuum the whole item, trying to pull up as much DNA as they can. There are plus and minuses of all those different techniques, but your job is to say, hold up, analysts, can we talk about this? How are we going to get the best amount of DNA? This is what we know the item has been through. What can we do? And talk about those different techniques so that you can figure out what the best path forward is. Next, the item is turned into, or I should say the DNA is turned into a liquid version. It's called an extract. It's through the extraction process. So you'll hear people say, well, the extract, we had to consume, 10 of it or half of it or whatever they may see. Whenever they say extract, all they're talking about is a liquid version of that DNA. That's it. After that, they do something called quantification or quanting. What that tells you is how much DNA is contained in that sample. And then they usually do Y as well, which says how much male DNA is contained in that sample. Another red flag for me there is, just because a test says no male DNA does not mean there is no male DNA in that sample. I have also worked on cases where the quant for male, so what the numbers told me in regards to how much male DNA was in that sample, said 0, but then we got a partial profile of a male sample. So again, the point of preliminary tests and serology, as well as quanting, is to simply provide a way for you to maybe prioritize items. You're going to want to go with an item that has a lot more human DNA and maybe do that item first. And then, in my cases, because I think like all of us get ones that are pretty old and degraded, we may start with not very great, but then end with the absolute terrible because we have to throw Hail Marys. We're in post-conviction work. So I think I just use it as a way of prioritizing my items in order to figure out what I'm going to move forward. After they quant it and you guys decide that you're going to move an item forward, that's when it actually gets into testing and then goes through the different testing techniques that we're about to talk about. I do want to put it out there. We are not going to talk about NGS or next generation sequencing. It's a very, very new technology. It basically, in a quicker speed, is able to analyze and test on way more markers. I believe the last I checked was around 150 locations, and it's just a very new technique that I have not seen a lab using yet. But I wanted to throw it out there, so at least if you saw NGS, that's what it means. And then finally, when they're getting results, there's a relatively new program called probabilistic genotyping software. It is not a test. It is a software that takes statistics or applies statistics to the results that you got from your DNA test. So your DNA test spits out results. An analyst will then input those results into a statistical program called probabilistic genotyping software. And then it will spit out a likelihood ratio or a statistic of how likely it is that you're based on different hypotheses, which we'll talk about. We won't get too much into PGS. One, it's relatively newish, so most post-conviction cases won't be like, it won't involve that. And also, I think it's a topic for itself. I think it is something that has its plus and minuses, and I would love to debate someone on it. So if you're a fellow nerd like me, please send me an email and let's talk about PGS. So what are the common types of DNA tests that we are doing in the criminal system right now? So the most popular golden star where most law enforcement wants to start is something called PCR or STR. What that is doing is, again, depending on your kit in your state, but I'll talk about Michigan, we are testing at 23 locations and then the one sex chromosome, which tells us whether or not there is at least one male in your sample. The reason that they like to use that test is it's more discriminatory. It also can be interpreted with these PGS or these statistical software like StarMix or TrueAllele, and it can be used in CODIS. CODIS is obviously a really good tool for law enforcement. So when we want to be able to make sure that our sample can be put into CODIS. And as I talked about, different kits, different labs, you just got to find out what your lab is using. Especially if you're going to try to get CODIS access through a private lab, that's a whole nother issue. And so I would recommend that prior to starting, you contact, if you are using a private lab, you talk to them about CODIS and what some pitfalls may be before you even get started. YSTR testing is a different type of test. It tests on the Y male chromosome that is passed down in a direct line from your grandfather to your father to your son and so on. As a born female, I will not have a Y profile. It will only be for males. That is one of its biggest limitations, is because of the fact that every male in a lineage line will all have the same profile. So if you have two brothers, which happened in a case, we had one of our exoneration cases, we had two brothers accused of the crime. If we had used YSTR testing, I couldn't say it was brother A or brother B because they share the exact same profile. So if you have a case where maybe, you know, a father or a brother or an uncle or someone in the same line could be the other suspect, then you really need to be aware of the fact that they're going to share the exact same profile and we cannot discriminate between the two. The other problem with YSTR, I guess, limitation is that it cannot be uploaded in CODIS. So if you do CODIS or you want CODIS as your end goal, you can't use YSTR testing. The great part about YSTR testing is it eliminates the female from the sample. So when you are dealing with especially in sex offense crimes, and there's a female victim and a male perpetrator, if you're doing something like a vaginal swab, it's a very intimate sample. So it's going to contain a lot of the female victim. What YSTR can do is take out that female and only leave you with what should be the male perpetrator, as long as, you know, the victim didn't have other consensual sex prior to the crime. So it is really useful. It just depends on what you're doing. Mitochondrial testing. This is, I think, getting pretty absolute right now, but I want to talk about it just in case you're reviewing a case that has it. Mito testing is the test that we do on hair. So when you have a hair strand, unless you have that beautiful root at the end, which can go into any of the other tests, if you're only left with the strand and there is no root, you cannot do the other type of testing. So you have to do something called mitochondrial or mito testing. The limitation with that one is sort of like YSTR testing. It's going to share your maternal line, so your mom's line. So the mom is going to transfer or have the same profile as her kids, and so on and so forth. The sort of difference between mito and Y is that mito will actually still test for males. So me and my brother will still have the same mito profile. It's just going to be the exact same as my mom's. So again, it's just really limited. It's very expensive. Not a lot of places do it. You have to have a lot of hair, and sometimes it works and sometimes it doesn't. So because there are such limitations on it, if you have only a hair shaft left over, I would probably wait, because there is new technology that is coming out, where they are starting to do STR on regular hair shafts. To me, it's still in the baby stages and I haven't seen a lot of great results on it. But if you have a bunch of hair and you want to go ahead and consume a few pieces of hair to try for it, why not? What do you have to lose if you've got the money? But just know that, mito testing is very limited, and hair shafts sort of are terrible items right now, but hopefully in the future that'll change. I sort of just touched on this probabilistic genotyping software. Again, it is not a test. I want to reiterate that because I've heard lots of people say, well, they did that PGS testing and it showed my person. It's not a test. All it does is take statistics and apply it to your DNA tests. And usually it occurs when we have a very complex mixture, which means we have a bunch of people contributing to one sample and we can't separate it out. So we use PGS to try to apply statistics using hypotheses that can say whether what the likelihood ratio that your person is there. This again should be a whole other topic. I think it's extremely confusing for juries because they have to listen to statistics, and I have a hard time explaining statistics, and I work with this stuff a lot. Imagine what a juror is thinking when they're hearing these likelihood ratios, because they really don't understand its limitations. So I would just say, if you have any type of PGS in your case, consult an expert, because there may be some things that you could work with. I do also want to say that the analysts are responsible for inputting the data into StarMix. I have seen where an analyst makes a assumption based on how many contributors they think are there, because that's what they have to do. And then some other analyst was like, well, I wouldn't have said that. I would have said this. And that would completely change your results. So wherever there is human, there's always a possibility for error. And even though the statistical program is based off statistics, it really matters what information is inputted into the system. So what does it actually look like when the machine, the DNA test, pumps out its results? This is what you get. It's called an allelic table. I call it a profile chart. In every single case that we evaluate, we do one of these to make sure that we have all the data and there's nothing else there that may have been missed. So starting with, I did sort of lie, I'm going to give you a little bit of bio. Hopefully you remember that you get half of your DNA from your mom and half from your dad. So you're going to get one allele from your mother, one allele from your biological father. Those can be the same alleles. All they mean is allele is just a number. So what is your number at the specific location on the DNA? So here, for example, or I should say also, the location called a locus or a loci for plural. I just call it a location. I think it's a lot easier to talk about rather than say locus and loci. So I just say location, which just means where on your chromosome are we talking about. So you'll see here that on the left-hand side that the locuses are all your different locations. It does not matter to you as a practitioner what D3S1358 means. Does not matter to you. Just know that's a location that they tested on, and then the results are on your right-hand side where it says 1515. So what that means is this sample, which I will tell you is a known sample of someone, they at that first location are a double 15. So they inherited 15 from their mom and 15 from their dad. And then as you can see on the second one, they actually got different numbers from each parent. So they got a 13 from one and a 16.3 from another. So both are totally acceptable. Sometimes you can get the same number, sometimes you'll get different. But what you cannot say without more additional information is, did mom give you the 13 or did dad give you the 13? All you can say is this person at that location has this number as their DNA signature. And then I do just want to make a note that they are testing on that sex chromosome. So if you see Y or at least one Y, then you know there's at least one male contributor to that sample.
We've got a question.
Okay.
We've got a question about PGS. Can you explain how the statistic that you get from something like STR or other tests is different than the statistic that you get for probabilistic genotyping?
So they're using two different statistical bases. So one's a likelihood ratio and the other isn't. And unless you go to like a statistics 101 discussion, I don't even want to even get into that argument of what one is over the other. They're just two completely different statistical ways of evaluating something. I think that's the best way to describe it. So it is not the same as back in the day, you know, you'd get a 1 in 100 quadriceptillion that it's your person. That was a different statistical basis than what a likelihood ratio, which is PGS, is using.
Thanks, Lori. We can continue.
Thank you. Electropherograms. If you're a cool person, you're going to call it an egram. We just say egram because it's a lot easier than saying electropherograms. All this is the chart that is created or the graph that is produced when the DNA comes through. So I took this chart and created this profile off it, or this graph and created that profile chart off it. I do really recommend that you go back to the egrams, because if you aren't doing that, then you may be missing data that you didn't know existed. So again, best practice in our office, every single case, if there's DNA involved, they're doing a profile chart and they're reviewing the egrams. You can see at the beginning, the first little chunky section, you're going to see your X and your Y. So I mentioned that if you ever see a Y, which is this peak, then that means that there's at least one male sample in it. I apologize, I should have switched these to colors, but if you get yours electronically, yours should be in color, and all these boxes along the top will actually be different colors so you can differentiate. It's very hard to see, but these are all individual locations here. So going to the second line, I think it's a little easier to see it. This break constitutes a different location. So one location is here, and then this is another break, so that's another location, and then that's another location. So what you're kind of doing is grouping your alleles based on your locations and then recording what the information is there. So on the first one, I would use the top number because that's your actual number. So that's your allele or that's your DNA signature. So I would say 13. And then the next one is 15 and then 16. And those are all at the one location. Going to one that might be easier to see on the screen at the end for penta D, which is again just a location. I have a 5, which is your top number, and then an 11, which is your bottom number. You'll see that peaks have different strengths, and there's many reasons for that. What I just like to say to people, again, as attorneys and practitioners, you're just trying to determine what, if anything, you can talk to an expert about. If you start to see things like that weren't called by the lab, then that's something you need to have a discussion with them about. And then every lab's going to be different, but it'll usually tell you your panel or your test kit at the side. That's really important when you're working with experts or when you're evaluating if there's a new test that can be done. You want to know that kit information. And then it should usually say, again, depending on your lab, either the sample name or the actual specific tag number that they were given, so that you know which egram belongs to which item. There are ones where we've received from the Michigan State Police that are like, 400 pages with a bunch of different egrams in them. So you have to be able to locate which one belongs to which item, and they always do it from their tag numbers.
Lori, we have two questions.
Yep.
So the first is, does every lab test for the same number of locations?
No. Depending on your lab and depending on the date of the test, you are going to be testing at all different locations. The amount is going to be completely different and the locations will be different. Kits are what matters. So DNA kits, every lab can choose which kit they want to use. There are definitely overlaps, and there's a lot of labs using the same kits, but there's not one kit for every single lab who's doing DNA testing. And the majority, I would say, of the locations do overlap in the kits. So if you have 5 different kits doing the exact same test, you're probably most likely going to get the majority of overlap. But there are times where a certain kit, like the 26 location kits, are going to be testing at different ones than my state lab who's using a 23 location kit. So every kit varies on which ones, but they do try to use, I would say the majority of them are very similar or the same.
And we have a second question. Can you speak to the considerations that go into how a DNA analyst determines the number of contributors in a mixture?
Yep. So in the next slide or a few slides, we'll talk about what are artifacts, which I call computer glitches. So not every peak, so a peak is your little like lines, not every peak is going to be actual DNA. There are times where there are other things that I call glitches, non-scientific, I know, but they're glitches that cause what looks like DNA but isn't. So there's a few ones like stutter and things like that. So the analysts have to determine whether or not something is first in fact DNA. And once they do that, they then have to analyze if whether or not how many peaks or alleles are at one given location. So what I like to do, for example, is in the first location, which I hope you guys can see my mouse, there's this cluster group of 3. So 13, 15, and 16. What that tells me is it has to be most likely, so I shouldn't say it has to be, but it is most likely more than one contributor, because we get one from our mom, one from our dad. We can only have a maximum of 2 unless you're a super rare genetic mutant. But most of the time, let's keep it simple, you're going to have to only get 2 from each person. So if there's any more than 2 alleles at a given location, that means there has to be one more contributor at minimum. So we can usually determine what the minimum amount of contributors is, but we cannot determine what the maximum amount of contributors are because we can overlap. And there's dropout, and sometimes your DNA isn't left behind at every single location. So we can't say maximum how many there are, but we can say minimum. It's most likely, 1, 2, or 3. In this case, only looking at, I think I'm at like 10 locations because I zoomed in so we could see it. This one, I would make the conclusion that there's at least 2 people, and that's because at one part right here, there's 3 alleles. At one part here, which is a location, there's 3 alleles. And at one part here, there's 3 alleles, which means, more than 2 people. So I would also say that is room for interpretation. I've seen analysts who call things DNA and some who call it an artifact, and that could change how many contributors there are. So again, it's more red flags should be going off. Ask some experts some questions when you see that.
That's it. Thank you so much, Lori.
Thanks, Adina. So ladders. Ladders are basically just telling you what numbers or alleles could be at any given location. And this doesn't mean that every human in the world shares these alleles. All it means is it's the most common. So for example, the groupage right here, is a first location, so specific area on your DNA. These are all the possibilities. So we've got 12, 13, 14, 15, 16, 17, 18, 19. The majority of us are going to have one of those at that location. Now you're going to get something called an off-ladder allele. And what that means is that someone, if it is true DNA, has an allele that is not normal or ordinary for that location. And so they would have an abnormal allele and it would be called an off-ladder. The other possibility to that is that it's just an artifact or a glitch, or something that isn't DNA, but something funky happened when the DNA test occurred. And so just because you see an off-ladder allele, don't be like, ooh, I got a weirdo, contributor. And if I find this weirdo contributor, it's going to be really, discriminatory to that person because it's so rare. It could just be an artifact. And again, that's something, start talking to an expert, because if you're testing the same item a few times and you're still getting this off ladder, again, that's more likely that it is actually a weird allele that someone has and not a computer glitch.
Lori, can I drop in with a question?
Yep.
Can you explain the difference between an off-ladder allele and a microvariant?
No, I can't.
We'll,
Dina,
we'll
would you like
that.
to explain?
We'll save that for DNA 201 then. That's great. I'm going to write that down and
It's too
get in touch
scientific
with
for me.
this question answer. Please continue. Thank you.
So this is just another example of what an off ladder will look like. And you'll see that I used a beautiful color egram, which I should have for the other one. So I will change that. So you can see the THO1 is your location. So location on the strand. You'll see that we have a 7 and an 8, which are really, really high peaks. So again, that first number being 7 and 8. So those are your alleles at that. But then we have this weirdo, this OL, which they're calling an off ladder. And again, I want to make it very clear. It could be an artifact, a glitch, a mess up in the system when the testing occurred, or it could very well be DNA and someone's number, allele at that location is just not as normal as the other ones, and it's a rarity. So therefore, that could be real DNA. It's just, they're not part of the ordinary numbers that we usually see. Threshold. This, in my opinion, is a huge, huge reason to consult an expert and get expert opinions. When an analyst does a test, any type of DNA testing, they are limited to what their procedures are, their standard operating procedures. And there's reasons for those and lots of technical stuff that goes along with them. And one of the things they have to follow is something called a threshold. A threshold, I like to think of like baseball. Hey, Midwest, plus I'm Canadian. I grew up in a huge baseball family. So baseball just makes sense to me. And what it means is that DNA is like the home run derby. We don't care about in the park hits. We don't care if you got on first, second, or third. If you don't hit it out of the park, that's the only way I can call a DNA an allele. And so every lab, based on their standard operating procedures and how they have brought their systems on board, will have different levels that they call DNA. So their thresholds are going to be different. So in this case, for example, this was a Michigan State Police case. Their threshold at that time was 150. And what that means is this peak has to be above 150 in order for it to be called DNA or an allele. If it falls below, it doesn't meet their threshold and it's not what they consider to be real DNA. One problem with this is it can change. MSP, for example, when this test was done, it was 150, and then the next month it was 250. They will, change tests and change their machinery and then recalibrate it and then say, well, that's the need for increasing it from 150 to 250 or whatever it may be. There are cases where you can have an expert, a DNA scientist, So not an analyst, but a DNA scientist actually opine on those raw data, so those egrams, and say, whoa, 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 there is actually data here. It can be called, and it could help to either, exclude or include or whatever, the case may be. So I think thresholds are a big deal. I understand the reason for them, and I'm not fighting that. All I'm saying is that if you have data that may not reach that laboratory's threshold, get an expert opinion, especially if it's data that is going to help solve the case or determine whether or not the person is included or excluded. You want to make sure that you're looking at that data that's below the lines. And kind of piggybacking on that, when the machine spits out their data, sometimes the peaks are so strong, they're so high that they have to really zoom out. And because they're zooming out, you may be missing blips that are much smaller, but they could just be, a minor contributor in a very heavily soaked intimate sample, for example. And so we just might not be seeing the data, which is why it is so imperative that you get all the data, which I'll talk about in a little bit, and you actually review the egrams and you actually see, is there more data here that just wasn't called? And I'm not saying that every case you get when you see something below threshold is going to be DNA. I'm not saying that. I'm just saying that if you see that, red flag it, bring it up to an expert, because it may be something that you need to have reevaluated. So I think I said this a bunch of times. I call them glitches. They're scientifically called artifacts. I just understand it as it's a glitch in the process. It's not actually real DNA or an allele. The most common you're going to hear, or I hear, is stutter, which occurs, it's a fake allele either before or after the real one. It usually occurs before, but sometimes it does happen after. And then there's a few other ones like pull up and diblobs. If you're hearing any of these weird words, again, red flag, contact an expert. That to me is my biggest advice. And I did just want to show on this. So our actual allele is the 16 because the peak is really, really high here, which means it's strong. But then there's this little guy before, and he is really small. And the analysts use a percentage of what that peak height is in order to determine if it's most likely stutter. And that will change with the labs. It just depends on the kits, depends on their validation at that time. So again, if someone's calling a stutter, just ask questions. It doesn't mean something went wrong, but it could have. I provided an example of a lab report. It's really hard to discuss lab reports because they're absolutely so different from lab to lab, even just from private to public. So I just recommend looking at your labs really closely. You want to notice things like, what are the item numbers? What are the specific tag numbers to each swab, to each extract? So they could have a tag number for the item, then a tag number for the swab that they used to take the DNA off the item, and then a tag number for the extract, so that liquid version of what they created from the swab to be a different tag number. So just start following your tag numbers in order to understand what was actually tested. A lot of the times, especially with, let's say, vaginal swabs, there could be 2, 3, 4. You want to make sure you have the right one that you're following, because maybe the ones that weren't analyzed are really golden items for you right now. Also, they will tell you which type of tests you have. So if you don't want to go to your egrams right away, you can look at the report. They should say what type of kit they were using. So when you're dealing with a expert, you can say, oh yeah, I saw they were using whatever, PowerPlex Fusion system. I do want to talk about, I think there's 2 or 3 states that I've seen this where they actually number their reports in order starting from 1, which is phenomenal. And thank you so much, State Labs, for doing that, because what that means is that there should be a succession in every single report you should have. So if your numbers go 1, 3, 5, 6, 7, 8, 9, you want to be asking, what what reports you're missing so that you make sure you have all the details. And then finally, I do want to mention this because if you're reviewing old cases, it was a big, big, big issue. Before we used to call things the epithelial fraction and the sperm fraction. Where that came from is, especially in sexual assault cases, you would be doing a vaginal swab, for example, and finding the female usually isn't that helpful because we're trying to identify the perpetrator. So they came up with a way of separating out the female DNA from the male DNA. It was not a perfect science. A lot of the times the female would leak or the male would leak into each other, just because it wasn't perfect. And so when they were calling it, the male sample and the female sample, or the epithelial, which goes towards female, and the sperm, which goes towards male, it was very misleading, because just because there was a sperm fraction does not mean there was actually sperm. It was just their way of calling that fraction, the male fraction, what they called sperm. And so in cases where, male sperm shouldn't be in places, especially with child cases, when someone is saying sperm fraction, someone's hearing sperm, and that is not what that means. So nowadays, people are saying fraction 1 and fraction 2. Again, much more, it's cleaner because it actually means what it says, which is just we're separating one swab into 2 separate samples, hopefully trying to get the male separated from the female.
Great. Can we take a question?
Yes, absolutely.
Can you speak more to making decisions about the relative peak height when calling something in stutter position an artifact or a true allele?
So again, it's based off of taking the big peak, taking the little peak, dividing them, and then determining what that percentage is. So I know Michigan State Police, for example, at one point was 15%. So if it was less than 15% and it was in that location 1 or after, that's how they would call it stutter. So it just depends on your lab and what their validation studies are, and they should have standing operating procedures that they have to follow for what they mark as stutter.
When in doubt, consult an expert. Thank you.
We should have a flag that just appears that says when in doubt, consult an expert. And then this just goes on to talk about other things you may see. I don't really think I have to go into too much explanation of it. Just read your reports. And one nice thing is most of our state lab reports will actually identify where they sent the evidence back. So that's really helpful in post-conviction land when we're trying to find the evidence. If you can go to your state lab report and they were so helpful, then hopefully you will find out where it went. I do just want to quickly talk about CODIS. Again, you can only use STR testing for CODIS. You cannot use YSTR testing or MITO testing and submit it into CODIS. It is the DNA database that we use. There are local ones like statewide and locals, and then there are nationwide ones that are controlled by the FBI. In order to get access to put your item into the different levels, there are different requirements. Again, you don't have to know that. You just need to know that when you're talking to your analyst or working with a private lab, have a CODIS discussion before any testing begins. In fact, I have CODIS questions and discussions before I even send my evidence there, because if they can't satisfy CODIS and it's something I need in a case, then I'm not going to send my evidence there. So please make sure that if you're using private labs that you have these CODIS discussions. I get asked this all the time, and maybe I can just pre-record myself. You cannot pull a profile of someone who is in CODIS out and compare it to your evidence. CODIS is only an uploadable device. So you put your profile from your evidentiary item into CODIS, it hits and then says, here's your overlaps. Another thing that I just ran into in our last case, so I want to let you guys know about, is that just because your suspect's profile or someone you're interested in is in CODIS doesn't mean it is tested with the same updated kit that you're using. So in a case we just worked on, we had a suspect who we knew was in CODIS, but it turns out that the data I had on my partial profile was actually not the locations that the CODIS profile of my suspect had. So they weren't able to compare, so he wasn't getting a hit. So you just want to be really careful with, just because someone's in CODIS, you don't just say, well, they're in CODIS, it should have hit. You have to ask, what kit was that tested with and what locations do you have? Again, that's not for you to determine. It's for you to contact your CODIS coordinator and have them pull the profile and see what kit they were using. And I do also want to make a comment about something called a keyboard search. What that does is you can get a court order to have your CODIS eligible lab, so here the Michigan State Police, search your evidentiary item profile without submitting it. There are tons of red flags or red tape. I've never had it happen. It hasn't been able to happen because there's CODIS is so specific and strict. And labs, especially state labs, do not want to have their CODIS pulled from them. And so, you know, there is this thing of a keyboard search. Defense tries to pull it and say, well, just do a keyboard search. Yeah, it's not that easy. It's definitely a discussion to have and say, hey, I've heard of something called a keyboard search. Can we do that? But most likely than not, you can't. But I am always up for asking the question and being told no.
Lori, can we pause for a question?
Yep.
So in talking about compatibility across labs, maybe you have multiple rounds of testing. If each lab is using their own kits or their own software, can they opine and review one another's results?
So the lab analyst cannot, but a separate DNA expert can, because they will take that lab's validation studies and standard operating procedures, and they will see what's going on and see if there's anything they can opine on and determine whether or not there's, you know, missing data or incorrect data. But an analyst who works at a lab cannot analyze another lab's results.
We've also got a few CODIS questions.
My favorite.
So first, can you enter a partial profile into CODIS? And if yes, how much do you need?
Yep. So every level is different. So your state locals versus your federal is going to have different requirements. So for example, I believe this was the FBI's before 2017, it was 13 locations. Or sorry, that's how much they're storing, but the minimum was 8. So you can enter partials in. It just depends on if you want local or federal and what their requirements are at the time. I think the last one we had was 6 or 7 locations. So it definitely wasn't a full profile, and we submitted that to local.
And then a second question about keyboard searches. So you mentioned that you've never been able to accomplish a keyboard search. Why would state labs be unwilling to do a keyboard search? What's the down?
So first of all, CODIS requires a lot of things from a state lab to satisfy in order for them to even touch the CODIS database. And the reason is that it's people's DNA, and they're trying to make sure it's protected, it's not abused, it's not taken advantage of. And so they have requirements, like I think I list them there. So first of all, you have to say that there was an evidentiary sample and that the evidence related to your crime in some way, shape, or form. So your analyst is going to ask you questions like, where did this item come from and what's its connection to the crime? You know, the police thought that the perpetrator cleaned their hands with a towel after, or something like that. And so there's different criteria that an analyst must, or a lab must hit before they can actually upload it into CODIS. And so if you break any of those criteria, you're not getting into CODIS. A lab can also only review and opine on a test that they're validated for. So if you use a lab that's using kit A, and you're asking your public lab, your state lab who uses kit B to put that, like that kit A in, that lab has no business talking about kit B because that's not their kit. So they can't be opining on that and thus inputting that information. So it's all about what we call validations and what that lab kit wise is able to handle. And if that lab doesn't have the same kit, if they didn't have a connection with the private lab, they can't take responsibility for that. So there's a form that you can do, an agreement that your CODIS access lab can have with a private one, but that has to be put in place. They have to look at their case reviews and their site reviews. They have to see their standard operating procedures. So basically the lab with the CODIS has to take full ownership of that private lab. And quite frankly, most state labs aren't willing to do that because they don't know the credibility of that private lab. So there's just so many red tapes in regards to, do they have the same kits? Did they set up this connection? Is the item relevant? Things like that really stop these keyboard searches from occurring.
Thanks so much.
Thank you. So I'm going to just quickly talk about masking because I think this comes up a lot. You really have to think about the fact, especially with intimate samples, so samples that are really, intimate to me, like, a vaginal swab or an anal swab, that is going to overwhelmingly control what DNA you have in that sample. And so I think of it like 100 black jelly beans, who's the victim of the sample, and you're trying to pull out that one pink jelly bean with your eyes closed after shaking it up. It's very, very, very difficult to do. And when you think of an extract, it is not like water where everything is contained in the same molecule and you're going to get a duplicate. It's more like salad dressing where, you may have extra garlic if you didn't shake it up enough. So when we're targeting testing, if there's so much of the intimate sample of the victim, you're going to have a really hard time getting the perpetrator, if there is one. So that's where we talk about, using different types of tests and stuff like that, having conversation with your analysts and saying, this item originated from A, I really want to get who touched it or who wore it last or things like that. Having those case fact specific discussions is really what's going to lead your testing plan. And then partial profiles, labs will call a partial profile if they do not get 2 alleles at every single location. And so even if they have 22 out of 23 locations, they'll still call it partial. You can always compare a partial as long as it's above a certain amount for inclusion, but for exclusion, if you don't match at 1 and it's a single source sample, it is not you because you have to match at them all. And then I listed some scientific definitions and sources. Those are really just for you to go back. If you ever get like a weird, word you hear and you're like, what the heck does this mean? Hopefully, you can find it there. So what do I do when I'm reviewing a DNA case is I start very much from the bottom, which is requesting all the data in the case. You want to make sure you're not just getting the reports. If you get the reports, you are missing out on tons of information. Here in Michigan, for example, we have something called an FSD-7, which is the form that you submit as law enforcement into the lab. On that is a gem of information, because what you will find out is what did the police officers and law enforcement tell the analysts what was coming and what were the case facts and how many perpetrators. And hopefully, you know about implicit bias and the fact that sometimes analysts may, without knowing, be influenced by information they receive. And so if someone's being told something that maybe is improper or a little bit too much information, then you want to be red flagging that, and was there implicit bias on the analyst's part. There's a case that a colleague of mine sent me where it literally was something along the lines of, I know this person did it, you just got to find him on the evidence. That is extremely concerning, to say the least. And that was found because she had requested the whole entire file. So when you get your full file, you're getting communications to and from prosecutors to law enforcement. You're getting anything that person knows. You're getting, what the submission forms contained, what were they interested in, and then you're also obviously getting all your egrams and supplemental data and everything we kind of talked about. And if you're going to have an expert review it, especially looking at egrams, you're going to want to obtain the raw data, which is the .fsa or .hid files. Those are the actual DNA egrams without printouts, so the non-PDF versions. And if your expert has any grain of salt behind their name, they should definitely know what those are and be pulling those up in their own programs. What I do next is we do an evidence chart. We track every single piece of evidence, no matter how material or non-material it is. We make sure we know what happened to each piece of evidence and where did it go? Was it submitted to a lab? How many times did it get submitted? What happened to it? And this is an example of one, and Adina created a great QR code. My templates are not beautiful. They're very simple, but they work. So all it's doing is in the first column is identifying your items. Again, every single item involved in the case. Then the property room, so the put law enforcement tag number, which is important when you're trying to transport your evidence and find evidence. Then if there was original testing done, it tells you what happened. Was it processed for prints? Was there no analysis? Did they, find positive for sperm or blood? And then lab 1, lab 2, lab 3, lab 4, whatever it may be. So for me, evidence charts are a phenomenal way to keep track of all the evidence in your case, and in a quick and easy manner, so that if someone asks me, what happened to print lift 1, I can say, okay, let me go to my evidence chart. Most of mine are not beautiful, but they work. So whatever works for you. I just recommend that evidence charts be done in almost every case you're evaluating, because you don't know what you missed. And you'll notice I break out each swab. So in the rectal swab, there was 3 individual ones. I need to track, was like swab 6A or 6B analyzed, because maybe we can go back now and test the other swab. Or maybe they only used a quarter of the swab and we should now use the whole swab. So make sure you put as many details in your evidence chart, and then it's going to save you when you're trying to discuss with your analysts or experts about what testing to do. So then, kind of like we talked about before, I take my egrams, I create my profile chart. So I just go through each location and list the alleles here. And sometimes they get really gross and they get pretty complicated, especially if you have an item that multiple people have touched or come in contact with. You may have, 6, 7, 8 alleles at a given location, which is not very helpful, especially in a complex mix. But let's say, you're dealing with more of a easier case. I apologize if you hear my child, she's having a meltdown. So first, what you want to do is eliminate your known samples. So again, I am not saying that, you after doing this can get on the stand, raise your hand and say, this is the truth. I found out that there's extra perpetrators and I am right. What this is doing is allowing you to review the data so you know if you can contact an expert. For example, in our CIU, we have about 800 open cases and we've received close to 2,000 requests for service. If I had to get an expert to opine on every single one of my cases, we would never get anywhere. So if the attorneys or the interns can start creating profile charts, eliminating their known samples, and at least say, do we think something funky happened here? Then we can get the expert involved. So again, I want to make it clear, I'm not saying that I make conclusions and then we release people from prison. That's not what happens. What we're doing is using this as a tool to streamline the bad cases out so that we can get experts on the good cases. So here, what I basically did was I then went through and took the victim's profile. So I called it victim V, eliminated them first because it's their vaginal swab. They are most likely to contribute to their own vaginal swab. So I took their profile and I X'd it out, which are those little white X's. And then I took the defendants, because in this case, the lab concluded that it was the defendant and the victim only. So I took the defendant's profile and I X'd him out. And then lo and behold, I was actually left with 2 extra alleles. So the circled one in yellow that didn't match my victim and didn't match my defendant. And that's when you go, okay, so what the heck happened? Because if you're telling me it's the victim and my defendant, and then there's extra stuff, some may jiving. And so this, again, is when you start to add your facts to the question and say, did the victim had consensual sex with someone else other than, the rapist? Did the victim, Was there one perpetrator versus two? What are the allegations? Could there have been contamination? Is it from the 80s where maybe, people weren't wearing gloves? So you start adding your facts to what can make sense of this. But in this case, what it seemed like to me is that maybe it just wasn't the defendant. And because the defendant wasn't matching at those two locations, that's extremely troublesome for who is donating or contributing those alleles. So without any further explanation of an innocent contributor or contamination, it's not really looking towards the defendant being the contributor. So what I really recommend is do your eliminations. Again, do not take yourself to court. Don't write an affidavit saying this. It's just to say, okay, there's something weird. Let's consult an expert. And then I just sort of told you, I take what the finding was of the lab, what the statistic was, how many contributors they say. I look at my egrams and my profile charts. If they're saying it's a single source, meaning only one person contributed, but I'm seeing 3, 4, 5 alleles at a given location, and I'm like, hey, wait, mom, dad, that's only 2. Why are there more than that? Then I know it's not single source. So start scrutinizing what the analysts are concluding. There could be a very honest, real explanation like artifacts or glitches or something else, or it could just be, cognitive bias or human error or something else. So we just want to be aware that, just ask questions with either experts or the analysts themselves and see if you can kind of get somewhere with that. I just want to talk about if you're working with experts, which I think we've said the word expert 645 times. But if you're going to deal with an expert, make sure you have the raw data. Again, if they're not asking for raw data, I'm very concerned with the expert you're using. They should be analyzing that raw data themselves and not just be relying on PDFs of egrams. Also have that open dialect with them. Is there something we can test? And just because there's something we can test doesn't mean it's going to move the needle in regards to innocence. But, is there something that we can test at a private or public lab? And then I've done this once. I hope to do it again. I just haven't had a case come up. If you had PGS interpretation at one lab done, so let's say they use StarMix. So remember that statistical program that takes results and spits out a statistic. If they used one program, go ahead and use a different one. So you can reach out to TrueAllele, Cybergenetics, and they can run using that raw data. You may get different results because while their end goal is the same, which is applying a statistic to the likelihood of that profile being in there based on hypothesis, while that's technically their end goal, they have very different ways of getting there. And I have seen where two different programs will have different results. They may be, slight variances, but at the end of the day, if the result is close enough to be an exclusion or a maybe consistent and included, that's a big deal, especially if a jury heard it. So, just because someone used a PGS software, see if you can get the other one to analyze it. Harder to get StarMix to do anything for free. But maybe if you're working with a state lab, you can see if they will run it in their system, especially if it was tested at that lab. And then, of course, for the other 400th time, the Quattrone Center for Fair Administration of Justice. What's really incredible with Adina and their program is that they will actually help you find an expert and fund the expert. So if you are not comfortable with anything we just discussed, or maybe you red flagged something and you're like, okay, way above me, I now got to get someone in, please reach out to Adina and Quattrone, and they will help you get that expert that you need. I'm going to throw this out there really quickly. Check your trays. This is really old school stuff, but I've seen it contaminate a sample before. Basically, in the DNA test, what they have to do is take that liquid version, the extract, and put it into little containers and then shut the lid and then continue. And it's almost like Battleship. They go from like 1A, 1B, 1C, 1D, blah, blah, blah. If your defendant or if your defendant was tested in the first one, there is a possibility that little molecules ran into the subsequent one. And so when you put your evidence in there, like a vaginal swab, which they should not be on it unless they're the perpetrator, they could have contaminated that sample. It is the reason that knowns are supposed to be tested in separate batches from your evidentiary items. It's a reason that they shouldn't be on the same trays to begin with. But again, we know more now than we did back then. So if you have a case where, in fact, it was tested in close proximity, again, get an expert, ask questions. And then to kind of cap it off, what I do when I'm discussing, so first I get the data, then I review what happened, then I start asking questions about what I can do now. So the first question I always ask is, what the heck was the collection technique? If we're dealing with cases 30, 20, sometimes 10 years before, they might not have been wearing gloves, which means officers or, you know, evidence techs or MEs picked up items without gloves and could have contaminated it. So you have to be asking those contamination questions to make sure that, you know, it's not that that's contributing rather than a perpetrator. Another thing in that I've had to deal with is that my ballistics unit up into 2007 wasn't wearing gloves. So if they analyzed a gun or the bullets and then they weren't wearing gloves, they're touching this thing, they're looking and comparing, they're going to be giving their skin cells off. And so they're going to be putting their biological material on those items. So when I go to test that, I'm actually probably going to pick them up, which isn't my perpetrator. So that runs into a whole nother issue, but just be thinking about what were standard practice. Were they wearing gloves? Could there be contamination? Because it is a big issue in post-conviction work. Fingerprinting is another big issue. Based on what type of fingerprinting technique they used when they used to put the powder or the substance on, they may have contaminated that item. Or may have really just made it useless for you to even pull fingerprints off. So not saying I would never go through with items that are heavily contaminated or have a possibility, but it's a conversation that needs to be had with defense counsel or the prosecutor saying, hey, full disclosure, this may be contaminated. And so just because we get a full profile that isn't your defendant, that may not mean that they weren't the perpetrator. So it's just discussions that you have to have. What I always go back to is what evidence was not evaluated, analyzed, or tested. And really, you know, one great example that we talked about is if they're taking multiple swabs off one item, usually a sexual assault kit. So let's say, you know, oral swabs, maybe they only looked at one and then they were like, yep, moving on to the next ones. Well, those other swabs are prime for you to now use if you could find them and they haven't been destroyed, for you to now use. Even these same items that if they took a swab and only chopped off half of it, that other half may have more DNA that the first half didn't have. So don't throw that item away either. So it's really just all about what was actually analyzed, even if it all comes from the same, you know, evidentiary item, and how many swabs can we now reevaluate? I talked about earlier the murder weapon and the whole idea of knives. They weren't thinking about touch DNA. And so they were just looking for blood. But now maybe we can do touch DNA off the murder weapon on the handle, let's say. Extracting DNA, I sort of touched on that earlier. If their extraction technique to pull the DNA off the item wasn't the greatest, you're not going to get great results. So maybe there's a new technique that you can use in order to try to get the most amount of DNA off that item. Stopping at quant. Again, quant is where they're like, hey, there's very limited human DNA here, or, you know, there's no male, so let's stop. We're not gonna go forward. That's perfect for you to then come in post-conviction wise and say, nope, let's go forward with those. It's just a presumptive test. It could be wrong. And especially in cases where you may not have the greatest items, you could definitely try evaluating those again. And the DNA test itself. So I think we've talked about it quite a bit. Different labs are going to be using different kits. And along the way, kits have become a lot more sensitive. And we are testing on a lot more locations and able to use a lot less DNA. So just because something was even tested in 2017, that is not a reason for me to close the case and not move something forward for more testing. I think if someone says prior DNA testing was done, so I'm done, that is very dangerous. There is always something you could do. It's just, is that going to be helpful and help you move the needle for innocence? And then if you have no items, everything's been destroyed, you can't test anything, is there a way that you can attack the reports and see whether or not, maybe there was a mixture issue, maybe there was, there's a new software like probabilistic genotyping software that you can use to interpret these complex mixtures. And so there might be a way to actually look at the reports and get new experts to opine on what those results were, or new statistical programs to analyze something that an analyst 10 years ago couldn't do, just because it was too complex. So just because you don't have evidence doesn't mean you should also stop there. Is there something you can do with the reports? I've also had where the labs are not testing elimination samples. So for example, let's say, it was a piece of someone's clothing, and then they get this profile and it's a mixture, and they haven't actually obtained even the profile from that person. So you just want to make sure that they are comparing and uploading all of those comparison samples so that you're able to start eliminating who should be in that sample.
Lori, we have got a question about RFLP.
Yep.
So, can you speak to things to look out for if a case has old RFLP results? Any tips or experiences you can speak to for what to do in that situation?
Retest. If anything has RFLP, it's very limited. It's beginner DNA stuff. If you have items that you can retest, stop even looking at the results and just move forward with retesting. It was just such a beginning science that it wasn't very discriminatory. And so I would just recommend, if you can, just retest. Same with blood typing. We didn't really get into that here, but blood typing was not consistent. It was an absolute terrible test. And if you have blood typing in your case, 100% move forward, do more DNA testing, because you probably, the blood typing results would be useless.
Thanks for that answer.
So we are actually at the end. So I guess my biggest takeaway from this is that you need to consult an expert for the 800th time. This is really just about evaluating your case and being able to have meaningful discussions. I am a DNA nerd. I love to talk DNA. So if you have any questions, please reach out to me. And I love brainstorming with people in regards to testing procedures and stuff like that, because I think the more minds you have involved, the better outcomes you have. So thank you.
We've got a little bit of time for questions here, and Lori, I will start with one that came in during the presentation. Who are these DNA experts? How does a DNA analyst become a DNA expert, and what does it take?
So I don't think I can say on a BJA sponsored Quattrone thing who I use, but if you reach out to me, I will tell you who I use. There are 2 or 3 scientists who have PhD in biology and DNA, and have really taken the time to understand the science. One person in particular is someone who actually creates DNA tests and items. And then he then opines on the results, not tested at his lab, but at another one. So for me, I look to credentials. I look to whether or not they have a connection to criminal justice and DNA. Finding someone that is not doing criminal justice DNA is not helpful to you. But I will say they are very limited. And I'm a little unfortunate if I give away my source, that they will then become well used and I won't be able to get a hold of them anymore. But there's about 2 or 3 that I'm thinking of. Adina, if you're talking, you're on mute.
Goodness, there's always one. Lori, can you recommend any DNA courses or books that you might recommend for prosecutors for doing this kind of work?
That's a big problem. It's a big limitation right now, and I think Adina and I have joked that I'm going to write a book next, just because I don't think there are really good sources for us. There's some out there that are like, intro to DNA, and they're written by defense attorneys. But I think the bigger problem is it's really hard to have a hands-on discussion if you're talking way too science and not practical. So that's sort of why we started this, Adina and I, was we said, let's come up with a DNA 101 for practitioners that isn't overly scientific, but gets them what they need to know. So unfortunately, I don't know of any. Students and attorneys ask me all the time, and I don't have a good one. If someone else has one and I'll look at it, I would love to hear it, but I haven't come across a really good one.
Thank you. So we have another question here. This is a question about a situation where you might have two distinct DNA profiles in one person, and what if that should be uploaded to CODIS? What if you have someone with an unusual genetic makeup?
So if you have an unusual genetic makeup, you can always upload it into CODIS. That's not going to restrict you. So if you have an off ladder, let's say, I think that's kind of what the question is going to. So if you have an off ladder, that can go in. Quite frankly, if you get an off ladder in your case, please call me, because that's like really cool. And the fact that if that person is in fact in your evidence, that's really damning evidence, because it's such a rare feature. And what was the first part? If you have two.
I think the question is, and if the question asker would elaborate in the chat, I think the person is asking about unusual cases of somebody having multiple profiles, either maybe they've had a transfusion or other unusual situations where testing
Yes.
from one part of the body yields one profile and another part of the body yields another.
Yes, bone marrow transplants are notorious for this. I used to get into the fact that if you have you always want to ask your client as a defense attorney, did you have a bone marrow transplant? Because that will change the genetic makeup of your DNA. And so there could be a very weird circumstance or rare circumstance where someone has received a bone marrow transplant, their DNA has changed, and in fact, they could have been there or could not have been there. I believe there is a famous case on that. I just can't remember the name of it, where that sort of same thing happened. So it's definitely possible. It's also, remember, with identical twins, they are going to have the exact same profile. So, if you have a bad twin, it's going to implicate the good twin, because they're going to share it, and we cannot do anything to discriminate against the two.
Thanks for that answer. If there are any questions in these last few minutes, please do drop them into the Q&A. But we are getting ready to finish up here. We are so grateful to Lori for this just stellar session, DNA 101, dealing with both the scientific aspect and what practitioners need to know. If this is your first time working DNA cases, we've got you covered with DNA 101. If you are working on a DNA case, if you are a DNA grantee and you need help, please do email me at the Quattrone Center. We create training opportunities like this one, and we also, like Lori said, like I said, we will help you find an expert. We will help pay for that expert. We are here as a place for you to go to make sure you're able to accomplish testing in those cases where it's appropriate. Right now, you'll see the FTTA feedback poll displayed on your screen. If you would go ahead and please answer those 3 questions. And that will be the end of our time together today. We are so grateful for your participation. This webinar will be archived both on the FTTA website, that's the Forensics Training and Technical Assistance website with RTI, as well as on convictionreview.net. That is the Quattrone Center TTA website. That's where all future DNA-related TTA recordings will be available as well. Again, I am Adina Thompson, the Quattrone Center for the Fair Administration of Justice. And Lori, do you want to take us out with a goodbye?
Yes. Hello to all fellow nerds, and goodbye to all fellow nerds. And thank you for joining us on the Thursday before a long weekend. I know a lot of us don't like to talk about science, but hopefully you learned something, and contact me if you need anything.
And what we always do, call an expert.
Good
Thank you,
one.
everyone.
Thanks, everyone.